Okay, good morning. Thank you for joining us to the ROR meeting. Please sign the blue sheets. Okay, this meeting is under the not well. Please read carefully. Okay, the meeting materials. This is the ether part if you can join. Thank you very much to Dominic for being the minute taker and Raul, Michael for the JavaScriber. Okay, this is our agenda for today. Some comments? We have 2 hours. Okay, are the milestones. I think we are working kind of well on that. Yeah. And, okay, our active internet draft. We're going to have some on discussion today. This is the related. We're going to have 2 from Georgia's today. These are the open tickets. 3 of them were consequence of the last meeting. We need a new version. No? It's yeah. Okay, we have new tickets, consequence of the last meeting. So if we need a new version of 6550, so I think a Reaper observation draft is going to help to us for that. And if we need a new mode of operation for Ripple, and if we have to include CLBR as into the data root, I think we should. Okay, Torles, if you want to join us for a discussion of the role mail list, thank you.
Oh no, I don't know if I can present with an X. Was a square? Good morning. Oh, should it hold it? Okay. Yeah. All right. Thank you. Yeah. Okay. Can I? Yep. Yep. So, so this is about the whole idea of using bit strings as addressing in role, and here is a little bit the marketing slide of what we are trying to achieve, high level, as something to sell it to a user. So the design team has the following email address. So if you want to contribute, please subscribe to it. It's a little bit too small to see it completely, but let me quickly try to summarize what the goal is. You have your role domain with the root node, and you want to have efficient forwarding in here. So you want to, especially in the stateless mode, be able to use the bits to route the packet all the way to a destination. And then also one of the things you would like to be able to do is that an application can, in a server, indicate which receivers should receive a packet. And so the example used here is, let's say, a lightning control application where you have a large number of lights, and the controller application would like to be able to say for a particular command, switch on, switch off, which light should be switched on and off. And in the classical IP multicast model, you don't have that option. Do you want to interrupt immediately, or?
Yeah, I just wanted to make a terminology comment.
Yeah.
When you use the terms client and server,
Mm-hmm.
you're trying to say small thing and big box.
Yeah,
All your slides are using the terms client and server, not as in client-server communications, which is a request-response scheme, but in the sense of things that are small and might be on batteries, and things that are big and are in racks.
right. So
whenever
this is
you say
right.
server, you mean thing in a rack.
Yeah, so this is a small 10,000 line of piece of software running somewhere, and these are, you know, all the lights in the hotel, whether they're small or large.
Yeah.
So yes, so the whole terminology is
really confusing when you come out of an area where the servers are the small things and the clients
Yeah.
are the big things in a rack.
right. Yeah, please let me know what the preferred terminology, let's say, on the application side is, and then we can adopt it. I've just, you know, introduced in some slides down the terminology for the components, but yeah, I don't know what the right terminology is at the application side. So yeah, so that basically would be one of the things we've never done in beer working group proper so far, which is bringing the ability to set bits up to the application level, and especially here in these control applications where the controlling software would like to be able to, you know, for individual commands very quickly change the set of receivers. That would be really a very big benefit. And the other, as I mentioned, is the power cost efficient forwarding, higher compression by using the bits.
On this client and server thing, servers have state, clients don't.
Sorry?
Servers have state, clients don't. That's where it comes from. So a light has a state, it's on or off, and the client has a procedure to turn the light on and off. That's where it comes from.
Well, maybe again,
Yes,
Simon Slupik.
well, would be maybe good to work out in the design team what terminology we want to use at the application level.
Greg Shepard, Cisco, on behalf of the beer working group. Torlis, you mentioned that we haven't specified imposition in the application layer within the working group. Architecturally, it's always been the intent, so I don't think there's anything omitting that. If you think we need to do something, you know, document something in a way that's unique to what the architecture is not cover, please bring that up, because there's a lot of work in that space right now. Not necessarily just here, it's kind of cropping up all over, like you've seen beer as a service, kind of same idea. There's also data center work taking place like this. So if you're going to present, you're doing TE at the working group, right? Are you talking about this at all?
No, not. That was just the basic. So,
Okay, because I think this should come up as a use case,
Right.
and maybe entered in the use case draft so we can track that.
Yeah.
And then if there is a gap in the architecture for host and position,
Yeah.
please bring it up.
by the way, much more fundamentally, and I think I forgot to put this into the slides, but I wouldn't like to have role do anything that should better be done in the beer working group. So anything on this API level for the application or so, I think should not be specific to role, but let us in the design team
Right.
rather
Fine.
get far
Just
along to
Communicate
make
the
that
gaps
argument.
and we'll pick it up. I mean,
Yeah.
we're all a big team here, right? We
Yeah.
hug in. Good. Thanks.
Yeah, Casper, on the terminology thing, there's also another pair of roles here, which is the sender and the receiver, or the source and the member,
Right.
And so on. Then maybe we can focus on that terminology and not try to call the sender servers all the time and the receivers clients.
Right, that would be one level further down into the technology. That's a lot more easy, right? So the multicast sender model where it's in control about the set of receivers for each individual message. That, but yeah, at the app, we would still need to kind of talk about the application level. You know, how you build what is a controlling server and then these client devices. So yeah, okay. So that was basically the idea to market the scope of the work. But it's not only multicast, but it's also meant to support the efficient transmission of unicast. And then, of course, the cool thing coming over from the beer working group is we don't have to bother about the constraints of working in ASICs that support terabits of bandwidth, rather the opposite. So everything is software in the forwarding that, you know, for us coming from the beer working group is a complete shift, because what was done over there was very much focused on supporting ASICs. So here's a little bit the first round of trying to come up with a short-term terminology for the components involved. So we would have the software or boxes, the server, and I called this 6 server node application. It wouldn't be running roll and beer, but it would need to be able to send packets where the beer bit strings or an equivalent like the set of receivers would be able to be indicated, so that this new model of the multicast would be accessible to that application server. Then the root node, that would basically be one of the roles of these blue boxes, which are the Ripple routers. So 6RR as a proposed term for the root. 6TR would be a transit node that doesn't necessarily have to have a bit in the beer string, so it wouldn't necessarily have to be a receiver. In beer, this is just called a BFR, beer forwarding router. And then 6LR would be the leaf, the receiver router, which has a bit which can act as a receiver, which you can explicitly address. And then also Pascal brought up the need that we also want to support even more lightweight nodes that wouldn't be part of the routing domain, that would just be hosts, receivers that just would, and that I think is the conclusion that we're reaching so far, would just be able to receive IP multicast, but wouldn't have the feature of being directly addressed by bits. So that's basically, you know, the current state of the overall architecture. And then that means there are 2 types of applications, right? One is the beer-aware application that does know it's addressed through a bit, and then basically the applications here that would only be able to see IP multicast. Greg?
Greg again, Cisco. I'm sorry if I missed this, and maybe we should pull this offline if I got to dig in deeper, but you've got bit assignments to links like TE and bit assignments to nodes like traditional beer.
Yeah.
And no modification of the forwarding paradigm for that to work? I haven't thought of it.
We'll get to it.
Pardon me?
We'll get to it.
Oh, gotcha. Okay. The expectation that 6LNs are also bit assigned? Or is that just...
No, that was exactly the idea, that at this point in time, we wanted to make sure that we can support 2 different type of nodes, one that would be part of the beer domain,
right,
and then one that wouldn't be part of the beer domain, that would just be accessing the unicast and multicast services
I
of
got
the domain.
that. I got being part of the beer domain doesn't necessarily mean it's got a bit assignment.
Right. So at this point in time, we would cut it down, because the whole, you know, exercise right now is to cut down to figure out the, you know, minimum delivery. So let's not do.
But the egress interface could be enough to specify that device. It doesn't have to be the device assigned a bit, is my point.
Right. Yes, there could be direct addressing to bits for them, but maybe the point right now would be, let's cut that option off. Let's keep that option to the full Ripple beer routers. Yeah. So this was my kind of first attempt. We haven't reviewed, found time to review it in the design team, of how I could see the forwarding plane. And in beer working group proper, we have some differentiation, which I'm going to talk about in the beer working group, about the beer TE forwarding and the beer forwarding. And now we have here in the roll side, we have one big differentiation over what we've done in beer, which is that we wanted to introduce also the ability to have lossy compressed Bloom filter based forwarding versus the explicit forwarding. So there are a bunch of issues to work through that are detailed in further slides. But on the forwarding side, really, maybe we could think about it in this simplified manner, where no distinction between... I actually think I missed one update here. I think I sent... Okay, yeah. So I thought I had written something here, but so the interesting idea here was that we may not need any distinction in the forwarding plane between the TE notion and the native beer notion, because in the end, the only thing we're trying to do is, you have a bit. For that bit, you're trying to figure out where to send a copy. What is your next hop? The question is, how is the next hop calculated, right? In the beer TE model, the next hop comes from an explicit assignment in the controller and would be different on every node, whereas in beer proper, it's calculated locally from the routing table, the next hop. right? So that fundamentally means that the control plane could be different, but hopefully we can come up with a forwarding plane, which we call, beer forwarding table, that wouldn't have to distinguish between beer and beer TE. Now there is one more key thing for which I have all these crazy not finished slides, which is that in beer proper we're resetting bits. And the resetting of the bits is something we're doing in beer and beer TE for different purposes. That's detailed in the further slides. So I've basically put these resets bit in here, but we also know we can't do the reset of the bits when we're compressing the bit string in a lossy fashion. So here we wouldn't have it. And the question also in the non-compressed forwarding is whether we want to have this reset bit mask, because it may be, if we don't compress it, it may be fairly expensive, right? So if we have a bit string table of 256 bit, let's say, this is kind of here the example, then every forwarding entry would need to have, of course, they could be compressed, right? But if we look at uncompressed, we have 256 by 256 bit for the reset bit strings, for these FBMs, forwarding bit mask, which are basically resetting the bits. And maybe that is too much state, so we don't want to have it from the state perspective. Now, they could be very well compressed, right? So, but in any case, this is kind of the current state of the slide, not right? Pascal.
Yes, Pascal Hubert here. I mean, we had documents from which we started this work right before this design team formed, and I think it was pretty clear in every document that we never need to reset any bit.
Okay.
And if you see a need, then you need to come up with it and justify it with the group or design team. But so far, there's no need to reset those bits. One of the big reasons why beer would reset those bits is to avoid loops, because this thing gets flooded. But in Ripple, it goes down a DODAG. And it's a nice property of the DODAG that you can only go down it. If you start going down, I mean, you will never loop. And so there is no need to reset the bits.
So is that
I know,
right?
right? So if you see another good reason, then come up and we'll discuss. But
no, I
so
think
don't
primarily
reset
we
the
need
bits.
to be very explicit in documenting the reasons why we're getting rid of the reset, and I wanted to make sure that we enlist and document them correctly, right? Because so far I'm not sure that we have actually done that work.
Okay, and then for Greg, because I will get the benefit of Greg being here, and the draft, right? We have another draft which has nothing to do with this work, or so little so far, which is about in the TE world managing duplicates and replication and finding out which transmissions failed, and that's going to be very, very useful in the wireless space. I mean, you've presented the draft at Beer, I guess. I had a collision, but yeah. And so actually Thursday we'll have a bar buff that I call POW, for predictable and available wireless. And this is the sort of work which would be useful for POW. So the buff is at 11 and we don't have a room yet. But if you want to attend, because you're not, are you on the DetNet list? I don't think so. I copied 6-ish, I copied 6low, I copied DetNet. Now, if you just drop me an email, you want to see what POW is doing, then please just drop me an email. I will add you to the list. Okay. But so in this case, we do need to reset bits, but it's a very particular operation. It's not at all this design here. In this design here, we go down the DODAG, we don't reset the bits.
Right. I mean, and these are, not really finished slides for these are working slides, right? By the way, there is a version update missing, so I'd already replaced all 6low pan with 6low RH in the slide deck that I thought I'd sent you. So sorry for the mistake. So basically, the kind of encapsulation that we're planning to use, there are slides missing. I had a slide here that is crazy. So because I had a slide with all the relevant documents, including Pascal's 6low document for the encapsulation option that would compress the beer header and then also the encapsulated IP packet. Yeah, these are complete wrong. Oh man, It's really nasty. So, right. So this was just, the reasoning why even, Pascal is saying that we don't have to reset the bit string, right? But even more so if we have the Bloom filters, we cannot reset them. And I could, yeah.
Okay, I got this.
Didn't change that much, but there were just only 2 or 3 slides.
Okay, I will show you in a minute.
Right. So I think the question of where do we have duplicates and or loops, right? So in normal IGPs, we're saying we have micro loops, right? So and we wanted to avoid creating duplicates and problems there with the reset, right? So are you saying, Pascal, are you saying that, for example, because of the way Ripple works, we would never have micro loops?
Pascal, in summary, yes. In practice, in Ripple, we have a additional header, which allows us to track if we are going up or down the structure. And we have this rule which says that if you're going down, you cannot go up again. And even if the nodes are not in sync in the routing table, they still have a sense of up and down, and the mismatch is found. And so the packet will never loop. The routing table themselves can indicate a loop, but the packet, as they follow this loop, will discover that they are having a problem.
So we would
the relationship
implicitly
of rank is
right.
not what expected in the loop. So
we would implicitly ignore bits that would have us go up again.
basically, yes. I mean, the bits is kind of a match, right? You've got some bits which match next a child, and so you go through your children and you kind of and the bits which identify this next hop. So all the routes which go through this guy if it's storing mode, or this link if it's non-storing mode. And it could be a Bloom. And so you add the packet and this thing, and that gives you whether this child or not is the next hop.
Right. So we basically would have a local reset mask, so to speak, to that would be populated from the routing table, excluding the bits that are not, quote, down from here.
Yes, for each child, you need to have the bitmap of what's relevant to be sent through this child. Right. And you could reset the bits, but
no, just ending the end with the bits of interest that I think is relevant.
Yes, the bit of interest per child. So that's what makes this so great in storing mode, because now your routing table is just a set of bits per child, as opposed to a route per leaf.
Right. Okay, so we need to correctly capture that, and also look into what the memory impact is of that implicit, end mask. But I think that sounds more like it's a per node reset mask. It's not per bit. So I think that should be fine. Yeah. No, basically your particular Ripple node. So you're doing an AND operation before you're even looking at the bits. You're ending to figure out which bits you want to look at.
Your routing table in storing mode looks like you have a state per child in the DODAG, right? Mm-hmm. And this state is kind of the bits, which are below this guy.
That would be stateful.
That's in storing mode. Right. In non-storing mode, you have a bit per interface, which is, well, anyways, per adjacency, right? So whether it's the same wire or wireless, or if it's multiple different interfaces, you don't really care. You have a bit per adjacency, a bit mask per adjacency. In non-storing, that bit mask will be basically the Bloom filter of this link, or the bit of this link if you're not using Bloom filters. And in storing mode, it's going to be the collection of all the bits of all the leaves, which are somewhere down the geodag via this guy. Anyway, you take the bit mask, the bits in your packet, you AND that with the state you have for that child. If the AND operation is not a 0, you have a match. If you have a match, you're forward.
Okay. So let's fix that up accordingly. I think we're running completely out of time. It's already 9:25. 10. Yeah.
You can steal from me. From the end of the...
Yeah, so Cosmo, a quick question. I'm a bit confused about those bits because this is a graph, not a tree. So at some point, somebody lower in the tree needs to find out whether somebody more up in the tree has assigned the lower tree a forwarding responsibility or not. And if you never reset bits, then multiple paths down that.
I'm not
graph
100% persuaded either, but I think we're running out of time for that piece. But
will all
I
be
wanted to
followed.
make sure that we really work
Not just
through this.
about
Yes.
loops, but
Yes.
it's also about duplicates.
So yeah, but this was the slide that I was missing, right? Specifically just to figure out if I have the complete understanding of the documents that have been written for the scope of this work here, right? So Pascal has the, his proposed architecture, purely the beer and roll level, not the, IP multicast overlay. Karsten has the rolled CCast, which talks purely about the solution, assuming IP multicast on top of it for the Bloom filters. There is Pascal's beer dispatch in 6-low, which talks about the 6-low RH extensions for beer, to the best of my understanding. And then the unaware leaves is that related to basically these nodes that are supposed to not be doing? So this I think starts this work. It's not meant to define right now the multicast part of it.
Right.
Yeah. So that would basically be the part of these leaves that should be very lightweight, don't have any knowledge about roll and beer, but would also need to get IP multicast through roll beer then. And then, yeah, so please, if there's anything more drafts, please let me know so that I keep the list of relevant documents. So, right. So there are a lot of things here, and I think I was trying to, yeah. So we're trying to limit the work scope by eliminating below the line or it doesn't work options, and I have more detailed slide on those. So I think the first consideration was, even when we want to address receivers directly with bits from the server application, we could still put everything into an IP multicast header because that one would be compressed by 6-low RH anyhow. And we already have socket API, so it helps a lot if we don't at this point in time try to figure out how to receive native beer packets that don't have IP multicast in them. I was first afraid of the overhead of IP multicast and we don't need it, but that would be the proposal of just thinking that the stack always has an IP multicast header and that we're appropriately compressing that with a 6-low RH. Then we did discuss to an extent how we can basically send packets optimally. I was thinking faked IP packets where we don't have an IP multicast destination, and we figured out that we don't want to do it, right? So remember all these discussions that we had when we're multicasting a unicast packet and figured out that's not something we really want to do because there are so many problems.
Pascal, yes, so just the problem is if you want to send the same packet to multiple unicast destination, you've got this problem of well, you could reconstruct the IP destination based on a bit. That would be easy, but the problem would be the UDP checksum.
Exactly.
And so we decided that for multicast, we would not use a bit to indicate a destination and set multiple bits at the same time, because then it would be different packets.
For unicast.
But for unicast, we could send one unicast to one person, and we could see the bit as a compression of the IP address. That's
right.
very
So
rich.
I think you said a little bit wrong. So if we send an IP unicast packet across this beer ripple solution, then you can only have set one bit to
Exactly.
indicate a destination.
One bit only we support. That's what I
Right.
don't find here.
Now, of course, there can still be false positives, but they would be recognized as false positives because of the IP unicast destination address, right? Only one node is supposed to have that IP unicast destination address.
Even if we use a Bloom, actually, because if the Bloom delivers to two destinations,
Right.
if the checksum is still part of the packet, that can be recognized, right?
Right, exactly. So I'm saying that even if a packet gets delivered to a unicast packet gets delivered to more than one destination, it would be discarded by all but the one right destination. So we're not changing the unicast semantic. True? You would have said it differently?
No time to discuss
Okay.
this. We need a day for this.
That's fine. We can think about, an interim. We have more time. Right. And then I think what I think what I was saying here about the transport, I don't want to bring in the definition of Pascal right now, but I think that was basically the conclusion, that we look into this transport mode only for the beer ripple routers and tunnel mode to the lightweight nodes. And then I think one of the open questions is where exactly do we want to have the destination semantic, right? Because is it really worthwhile right now to consider this for the storing mode, where kind of, summarize the benefit of the storing mode? Because I think primarily we're looking into the non-storing mode. Nope. I think we were going back and forth on that, so.
Beer is critical for storing mode because it allows you to save a lot of state. I mean, basically it allows storing mode in constrained devices. I mean, Carsten has been telling us so many times that he has never seen any storing mode ripple network in IoT, right? I mean, I've seen them in non-IoT because it's a routing protocol. You can use it everywhere. We ship it with storing mode with Cisco. But in IoT, you usually don't see it because of the load of information you have to store. That's because it's at least one address per leaf in your DODAG.
Okay.
With beer, storing mode becomes feasible because it's one bitmap per child.
Okay.
And
That's fine, but let's
it's
write that
critical
down
to
then
support
correctly,
it for
because I
storing
think that
mode.
value proposition wasn't clearly laid out.
Oh, okay. It's critical. I think for me, it's a lot more interesting in storing mode because it makes such a huge difference. It becomes feasible.
Okay.
Michael Richardson. So if I understood, Pascal, what you said is that beer reduces the cost of routing entries in storing mode to such that it's now low enough that it's maybe workable, but it does not change the order n dependency that storing mode has. It just reduces the constant significantly. That not true? Whereas non-storing mode has the individual nodes have no specific limit on how many they can support because they're not storing any content per node.
You still need to have information per leaf, but the point is, if you have sized your bitmap to say 256, just for this example, because your network is going to be 256 or something, then you need one of such bitmap per child, regardless of how many leaves you have. Now, you cannot have more than 256 leaves because that's the size of your bitmap, right? If you want to go beyond that, then you have if you want some elasticity, that's why you use Bloom. But then the more you extend this elasticity, the more false positive you're going to get. Well, in the traditional networks that we build, they are not so big that, I mean, usually we build like 30 devices in the network, right? And so 256 is already a very big network. Oh, I was not talking T right now. I was talking storing mode is non-T, is normal beer routing. That's when you have state that you look at this bit, this destination.
Do we want to, because this is at the core of the work, and I think,
Carsten, I just wanted to point out two things. First, there's a small sleight of hand here, because by limiting the thing to 256, of course, we make storing mode much more manageable. And then by reducing the state by a factor of 64, we also gain something. The other answer is the Bloom filter is one important parameter for a Bloom filter is how many members you actually have in the whole group. So if you have sparse groups, you can address the whole network with a pretty small filter. If you have dense groups, you need larger filters. I mean, if your group is 100%, you only need one bit, send it to everyone. But if you have dense groups, your filters get large.
But let's go back. So let me say, what I just want to make sure is that for every option that we're saying we want to work on, let's make sure we have sufficiently agreed upon value proposition, right? And I think this discussion was good. It, I think, showed that that is necessary and that I think we should converge, for example, on exactly the value proposition Pascal claims for the beer mode. So I had started here to kind of look at, the stacking, how this stuff works. Probably not correct here, but this is basically what I think we would need to work out. So this was the IP multicast over roll beer toward, in this case, a 6LN, right? So in this case, we have the server application. I'm in this section that's saying IP multicast should mean SSM really. So then basically we should be able to have a user level SDK that the whole stuff can be written at user level, that, on the application server, we can just send things into, let's say, UDP tunnel, which is typically the encapsulation we can do at application layer. That would have to end up at the root node. And then from there on, we would have the hop by hop forwarding beer TE. And then basically on the 6LR node where the bit is set, it would basically be uncompressed, must be compressed as a non-bit string multicast packet again, gets into the 6LN application, right? So that was kind of a little bit the starting point of, these are the type of diagrams I think we need to work through the end-to-end solution and the stacking of pieces. And to me, the core part is really also understanding the 6 low RH, kind of how small these headers can become with the bit strings, and compressing the IP multicast overhead away. So the unicast stuff wasn't done. This was all these consideration, I think, running out of time. Yeah, these were the things that we think wasn't working. And yeah, so I basically started to write down the multicast layer. Yeah, so yeah, so way too much text, but I think one of the discussions we're having in the multicast architecture side in the IETF overall is, can we do things more efficiently, better with SSM only? And yet now, obviously, that's one of the things I wanted to review. If that's sufficient enough, if we're requiring IGMP or MLD v2 with SSM indicating the source. And the key part, to cut to the chase here, why I think SSM would be highly valuable for this type of solution is because the source address in the membership join could exactly indicate the unicast address of the server, so that we don't need to have an in-network discovery which server is basically responsible for particular clients to receive multicast packets sent by a particular server, because that would otherwise be the typical ASM issue, that we have multiple application servers for different clients, they all send multicast, and you need to start assigning IP multicast group addresses to different applications. So you can forego this complexity when we're also adopting SSM as the mandatory multicast delivery mechanism. That was kind of the high level, and this is all details. Carsten?
Yeah, I have one comment on choosing SSM. In a single Ripple domain, of course, the source is always the root. So it's
no, not that's why I brought up the prior slide. There would be different application servers that are actually,
they're not servers. That's why you now can steal that and use it for something else, which is an interesting idea I haven't thought about much yet. But basically, the reason why multicast has SSM is to solve the rendezvous problem. And since everything has to go through the root, we don't have that problem.
No, yep, well, no, I think, but the rendezvous point is primarily overhead in administration and paying for the network operator. It's not an application level issue, right?
So
the application level issue is kind of indicating which source am I wanting to get traffic from, right? Now, and as you said, we can nicely abuse that to basically have the server source discovery built from the application level that way.
Okay, I have to think about that. The point I was really going to make is the whole thing seems to assume that the whole group is within one Ripple domain. And that's not IP multicast anyway. So we have all freedoms of the world to design something completely new here, because we are not doing IP multicast in the original sense.
No, that's true. But the more I can avoid having to, do something new in host stack of hundreds of different, client OSs. I mean, IGMPv3 itself took 12 years to get adopted everywhere, right? So
yeah, I don't know what the client is, but the guy up there who sends the data is going to use a UDP tunnel to the root anyway.
Exactly. So that's where I definitely want to have a solution where we have no OS changes. No offense meant to,
So we have a completely blank slate and can design something that we really
but
like.
on the client side, I think we should be very careful about how basically they would receive packets, and also make sure that we don't need OS changes there, especially on the 6LR, the ones that don't have any Ripple beer functionality.
Okay. Greg, again, I'm going to avoid that last piece, but just going back for clarification, if the intent with SSM is to use it to identify one of n number of servers for source discovery, that makes a lot of sense. But don't forget the discussions around an RP are moot with Beer. Sure. In fact, Beer doesn't care if it's ASM or SSM, and actually becomes effectively the Beer domain is like a virtual RP. So if you need to do some sort of redundancy, or you needed to have some sort of multiple source, the argument on the RP is just avoid that and stay logically within the architecture.
No, I wasn't making the argument about the RP.
Okay.
Carson was making the argument. I think the argument that you made afterwards, that we might have multiple domains and need to figure out how an application works across it, I think that's more important to understand.
Okay, thanks.
I tend to agree with Karsten on a lot of what he said. We have a new environment here, and there are things that we prefer doing and things we less prefer using. Injecting an address which comes from outside the Ripple domain is very costly to us. We would not like to see it in the packet if we can avoid it, because we need to compress it, or if we don't compress it, 16 bytes in the air. So, for instance, having every multicast packet sourced at the root for us can be compressed with 6 to 1 bit. Right, because it comes from the root bit, So that's very efficient. So if every multicast packet which is compressed this way can be sourced at the root and destination set of bits, then we have the most efficient compression.
My argument would be that the amount of state that I think I need here in the last hop Ripple router is the same that I would need for the clients having unicast IP traffic to a particular application server. So if to improve the performance of the system, all these application servers should use the IP address of the root node, so that basically you don't have to keep state for new IP unicast addresses. That's fine with me. That doesn't change the concept, right?
And the other thing that we could leverage is the fact that we have multiple instances in Ripple. So you could have the same multicast address which can be derived into different sets.
Okay. Anyhow, so that was kind of, I think, where we should stop here.
Closing point, yes.
Yeah.
There was a mention of reserving a day. There was the mention of reserving a day for discussing all this. I think I agree, because 1 hour, even 2 hours may be a bit short. So what about having a half day or a day at the next IETF meeting?
Oh yeah,
Yeah. This,
Well, no, unfortunately, I'm in some other place. I have to leave on Wednesday night.
So that I thought that was out.
Yeah, but no, I'll basically resend after all these daylight saving times, just the weekly meeting stuff, and then we can discuss in a weekly meeting if we want to have an interim with longer time. How about that?
Might be feasible. I mean, if people are interested in doing that.
Yeah. And I think I still like to have a couple of weeks to bring this into shape, that we have the different components really clearly laid out to work
Absolutely. Yes, Greg.
I just want to vote publicly that it's
Yes.
Everyone in the room on the whiteboard in 2 to 3 days is like a year and a half.
Yeah, that's the good interim. I'm not sure. I mean, there are also the WebEx interims. I wish we could do an in-person interim, but I'm not sure if we find an opportunity for that.
Downtime to eat, think about it, come back again, and you focus on it, get it done before you go. But that's phenomenal.
In this case, the WebEx is not progressing very well.
Right.
Okay. So
We
you,
need drawings, we need whiteboards, and we are not progressing.
okay, and we'll discuss this on the mailing list then, so we see how many days if we have an interim apart from or next to the next IETF. Okay, fine. Thank you very much for all the work. I'm happy that this is progressing.
Next round.
Hello, I'm Rahul Jadhav. This is a quick update about what's happening with the efficient route invalidation draft. We have, sorry. Okay. So we had received a lot of comments from Peter, from Liubing, from Georgios. Thank you. And most of the updates are based on that. So, so this is the first one I'm presenting. So one of the major changes that has been done, or one of the things that has been explained more, is related to how to handle multiple parents. So Ripple has this notion that you can have multipath routing. You can send the same DAO to multiple parents, and in such a case, how will DCO or the DCO handle the route invalidation? This is explained with an example. So this is the major update. Other updates, we are more in line with the security considerations of 6550, especially there are 3 modes of security: unsecured, authenticated, and pre-installed. So we have aligned our draft in the security consideration as to how these 3 modes are to be understood. Then there are some clarification, the deco sequence number choosing the initial value, some terminology, especially the tolerant to link failures. So this is the section title we had used, and this caused a lot of confusion. We had to reword the whole thing based on the comments from Peter and Georgios. Then the terminology, we had made a consistent use of terminology. We had made some duplicate text in this document from Ripple and 6low, so as to just make it more readable. Thank you, Peter, and everyone else, including Pascal, Georgios, and Lubing, for the review comments. I'll quickly move on to my next slide, which is the Ripple observation. Now, this is...
Just want to mention that for me, this document is finished, and we'll send it on now for publication.
Thank you. Okay, so we'll move on to the next presentation, right? Okay, so this is the draft which talks about most of the observations that we had while developing a solution around Ripple for metering solution. Having said that, it's not now limited only to the metering solution, but more other problems as well. So this document was adopted, but we have clearly mentioned in the document that maybe this document might not get published. We want to still keep this document around so that if anyone ends up fixing this issue in some other way, this could prove to be like a reference material, and this explains the problem in more details. Like, it gives stepwise explanation of what the problem is. Okay, so there had been a big discussion on whether DTSN is a lollipop counter or no. Look, most of the things I'm going to repeat from the last presentation. So yeah, this is in continuation to what we had presented before. Whether DTSN is a lollipop counter or no. Now, implementations are clearly confused about it. We have 2 implementations making use of different, different notions. Basically, Contiki is using DTSN as a lollipop counter, and Riot is not. And this is going to, this will have issues on interoperability. So we had a big discussion on the mailing list. Eventually, we realized that maybe DTSN could be a lollipop counter, or there are pros and cons with each of the approach. The primary problem with using a lollipop counter is that within the linear part of this lollipop counter, you have to maintain the state in a persistent storage. Now, this problem is in general with all the lollipop counters, including DTS and DAO sequence, or no, not DAO sequence is not a lollipop counter, but all the other sequence numbers. The problem is, for the linear part, you have to maintain the state in the persistent storage. Now, you have an application which is a very minimalistic application, and you just are hosting that application in a mesh network. Now you have this cost of keeping the data in the persistent storage. Now, will a deployment afford this cost? Can this cost be mitigated by using some sort of signaling mechanism? This is what we are checking if it is possible. Michael? Okay, so the next slide is about the DTSN. So we had a discussion, right? The primary problem with non-storing mode is the memory efficiency on 6LRs, but there are other issues that we found, we observed while deploying storing mode of operation. And DTSN tends to be one of the major, I mean, the way DTSN is handled eventually decides what kind of control overhead you have in the network. So DTSN is DAO trigger sequence number. Essentially what it means is whenever a new DTSN is received by the 6LR, it will in turn generate its 6LR or 6LN, it will in turn generate its own DAO. So what happens is when in case of parent switching, node switching, should the DTSN be incremented? Should, so the first implementer's dilemma is that should the DTSN be incremented with every DIO trickle timer? If it is not incremented with regards to DIO trickle timer, then we don't have enough DAO redundancy. Now, there is another problem with regards to DAO, that the acknowledgement mechanism of DAO, which I'm going to present in the subsequent slide, because of that issue, we cannot really increment, we cannot afford to not increment DTSN on every DIO trickle timer. And you can see implementation struggling with that. If you actually see, so Contiki initially decided to use increment the DTSN in every DI trickle, then it was a lot of control overhead, and then they decided to remove it. So clearly there is some room for clarification, or maybe a text saying how to handle it. Okay, yeah, so the second point here is, during parent switch, should node increments at DTSN? Should the 6LR increments at DTSN? Now this is important because now the route update for the subdo DAG routed at that particular 6LR has to be updated. Now, let's say for example, even if the parent node switch, hello. So during parent switch, also the same procedure. The primary problem with during parent switch, if the 6LR which is switching, if it increments a DTSN, the question is, other 6LRs downstream should also increment it or not? If they don't increment, then how would the route updation for all the subdo DAG take into will be handled? Now, one solution is that the 6LR which is switching also has the complete routing table, and it can push all the information. So that is most likely the way to handle it. But yeah, I mean, these are some things which I feel maybe clarified in the text somewhere. Yeah. Oh, hello.
But you can use this one, though. So I completely agree, Pascal, here. I completely agree with Raoul that we have to clarify those things. Just for history, it was a huge fight within Ripple. Some people were for the pool model, like DTSN pools, the DAO state to the parent. And there are cases where you want this pool, just like when you reparent. And some people said, we can be lazy. Those networks, they work when they work. And so the child should be free of sending DAO anytime. And so there is no restriction when the child sends a DAO. So even if you don't increment the DTSN each time you trickle, if you don't do that, then you have the expectation that anyway, the children soon enough on their own will decide to trigger a DAO. So the basic spec doesn't tell you that. And it's probably because we could not agree, and we really did not know if there would be use cases for Ripple where the push model, the child pushes the DAO periodically whenever it likes, or the pull model where the parent pulls with a new DTSN all the DAO from the children. Which one was the right model for which use case? We were not clear, right? Ripple was there before we had enough experience. So we left that open. So what Raoul is telling us is now we need to be more specific. Is there a type of use case where one applies, the other applies, what benefits of each model, etc. I mean, Ripple is fat enough like this. We didn't have much text on that, but this is a great discussion to have. And at some point, Ripple will be implemented in some vertical standards like, I don't know, TVA or whatever else. And when you implement an RFC in an alliance standard, then you actually say, I'm using this feature, this feature, this feature like this. So they will, today the design is like, they will have to decide if they want to push, pull, or do both, what kind of timers you have for sending DAO, what kinds of, when do you trigger those DTS, etc. It doesn't have to be the same for every particular alliance standards for every particular vertical industry. We don't know that there is a good answer for everybody. If we knew, then we would have written it in report.
So Michael Richardson here, and we have microphones. I didn't know we had local AV support. That's wonderful. So we should have, as Pascal just said, some things. I'm not really fond of alliance profiles because I just think they're dumb. But we have the applicability statements that we wrote, and clearly this is something we should have covered about push, pull, and this kind of stuff. If that was a clearly articulated option, and I don't think in 6550 that's clearly articulated that there's two models. Rather, here's some tools, put them together in some way, right? So I've advocated this before, and I'm kind of a bit lost as to why we're not further down, and I said that to you last week, right? This should be a draft. We were talking about leaving the observations as a collection, and I would really like you to pull that text out, this text about this thing out into a single draft that we can, get consensus on, and it'll be update 6550. I don't think we're ready to do BIS. I think we should have 3 or 4 clear updates before we try to revise it. And I mean, if we were to do BIS, just aside, one of the things we probably would rip out is all the security part because no one's implemented it. Okay. However, that statement is no longer true. I've learned that someone has implemented the security parts of Ripple. And so that's kind of interesting. So I'm glad we haven't started BIS because we would have, I think it's still important. But I would really like this to be in there. And there are other observations. Are you going on to those other ones now?
Yes, we are. So the other observation is with regards to the acknowledgement handling. There are multiple interpretations already, and there are different implementations with different interpretations. One is the hop by hop acknowledgement. So in this case, the acknowledgement is immediately sent by the receiving 6LR. There is a so what happens is if the acknowledgement is sent here and then the acknowledgement is sent above, like for example N1 sends it to border router or some other 6LR, if it gets rejected, then there is no way of informing the 6LR node downstream whether that the DAO has been rejected. So there's no way. So this is much easier to implement. The primary reason why DAO ACK is needed is so that an application on the node or the node knows that it has connected in the whole network, and that it can start its application traffic. What I'm trying to say is the current acknowledgement mechanism doesn't help you with that. There has been a lot of debate on this, but so Contiki initially implemented this, then went on to this style of hacking, which allowed like N2 will send the DAO to N1, and N1 won't respond back with an acknowledgement immediately. It will wait for the above upstream parent to send back the acknowledgement and then send an acknowledgement in response. So this model is okay, but it has issues like in terms of it has to maintain state. It has to maintain state for a long time, and that is costly. Another interpretation now, this discussion I had with Pascal. So one of the things that he mentioned was that whenever an upstream node takes up a DAO, it accepts the responsibility of pushing that DAO all the way upstream. Well, and if it sends an acknowledgement downstream, it means that the DAO will reach upstream. The problem with this approach is that if there is a negative acknowledgement anywhere upstream, this node doesn't know that there will be a negative acknowledgement upstream. So it's not possible for this node to eventually negative ACK because positive ACK has already been sent for them.
Right. So two things. First, I tried to get from the Contiki people, but they are not in the room right now, why they did that. They said, oh, it's a hack they made for a particular customer. So yeah, because they're actually shipping their code and there are actually products being built out of that. And I think this one was for intelligent power plugs or something. And they they really wanted to have like a very quick acknowledgement. And it's a very particular use case where this behavior kind of works. In the generic case, I don't believe it would work just because of scalability, your timers, or all those things, right? So don't, I don't think it's right to say that Contiki understood this. It's just that they knowingly did that hack for a particular use case where it was actually better for them, easier, and to just do the trick more nicely, right? So the design on the left is the official one in REPL. And like you say, the official thing is you take responsibility, meaning you take it to the end. If you can't, if you push it to your parent and your parent cannot accept it, you have to reparent. And if you're completely broken, then you have to poison. So it's wrong to say that the child will never know. Either the parent will handle the responsibility and push it, or it will detach. It might find a new parent and push it through that new parent. And even if that fails, then it will completely have to detach because now it cannot handle its routing.
Right.
So the whole point is, yes, you have methods to accept the responsibility and ensure it won't just stay there.
Right.
Something will happen.
So the method that you just described, it actually requires a lot of state again, because now while the parent switching is in progress, and if you are holding the DAO information, that means you'll have to keep it with you for a longer time.
You're supposed to keep a state for every DAO you have, not in any sequence, right? But every child, every address, you have a state, and you have to know if your parent is aware of it. That's one bit. You have to track
Right.
what your parent acknowledged and
Okay,
what it
okay.
did not, and you retry what your parent did not acknowledge till the point where it did. And that's part of storing mode. I mean, I don't think it's additional state. It's just what you have to do if you have acknowledgements.
Right. So, yeah, but I get that point. So basically what you're saying is the routing table already has that information along with the state, so which and we can have a flag saying that this has not been sent
You're
upstream.
synchronizing with your parent, kind of, right? That's part
Right.
of REPL storing mode. The hack is, oh, I'm synchronized with them. So when you have this DAO that you got from a child and it's not yet acknowledged by your parent, you need to know about this. There must be a bit somewhere which says that in your
Okay.
implementation.
But what about the problem that we faced is, let's say, for example, the acknowledgement is received by N6, and the application traffic is going to get started. Let's say, for example, it's a co-app traffic. Now, while all these things is happening in parallel,
You don't know
the
yet.
acknowledgements are
You
not
don't
getting
know
started.
when.
Yes,
We had that discussion.
yes.
REPL doesn't give you that.
Yeah.
So you know that the state is progressing through the network. You don't know if it reached the destination. So we discussed about, and that could be one of those drafts that Michael is talking about, but an acknowledgement by the root, all the way down. Okay, now I got it. You could add a mechanism like this. Maybe it's one of your slides.
Yeah.
Because we discussed that last time. And yes, this one I would agree with.
Okay. So essentially, what all the observations that we have what we have quoted is in context to Contiki or RIPE. We also have our own private implementation though, which ran into similar problems, and then we checked how open sources are handling it, and that's when we actually went ahead and actually included. There are a lot of other things that are not handled properly in open source. We have not quoted those because those are just implementation quirks, So we have not included those points. So the easiest way to handle this is, and without much storage requirement or any state requirement, is by having root acknowledge the DAO. This will be much easier. The only problem with this approach is that you can't do aggregated acts. You can't aggregate multiple acknowledgements in the same packet. So you'll have to send an individual because this is essentially unicast traffic back from the root to the node. So that is one of the downside. Another problem with DAO act, whether it is REPL is not very clear on how to handle aggregated targets. It certainly allows handling aggregated targets, but it doesn't do failure handling. What it means is, if you have multiple targets in the same DAO, if one of the target fails, what to do? There's no clear explanation. Now, there are implementations already which enable aggregated targets by default in the implementations, and it is absolutely impossible to get anything to interrupt the open source implementation at multiple hops. If you put 5 nodes on the table, all are talking to the border router, everything works fine. But the moment you try to scale a little bit, nothing works. That is how it is today. Handling node reboots. Now this we had a big discussion. Lollipop counter sort of handles. Again, the point here that I'm trying to make is Lollipop counter requires some sort of persistent storage, even though it is very small. It is only required for the linear part. It still requires persistent storage if you want to get a deterministic way in which the node can join the network. Deterministic means within a particular time bound, not like in few milliseconds, but at least in few seconds it should be possible. Yeah, the primary question here is, should deployment provision persistent storage for network stack, even though app does not require any persistent storage? So this is a big debate that we had internally inside our deployment solution. Handling resource vulnerability. Now this is this problem is with regard. I think this problem is in a way handled by other drafts now. It's about neighbor table and routing table getting full, and how to handle it if the routing table or neighbor table at an upstream node gets full. So how would the downstream node come to know about it, and how to handle all these scenarios? I won't go into the details of this because there is some work going on in the context of this discussion. Should transit information be optional? Now, currently the transit information is optional. Transit information contains key elements like path sequence and path lifetime, parent address for non-storing mode of operation, and it is optional. There is no way parent address can be an optional element for non-storing mode of operation. So it has to be mandatory. So these are some of the points that we figured. Aggregated target container aggregation can be optional, but at least the reception of aggregated DAOs should be made mandatory, so that the implementations care to follow that. How to do it? I mean, this is something that is left to discussion, but this is there is some idea that we have proposed here. Maybe some of the work will require separate drafts, like Michael mentioned. Even the acknowledgement work might be a separate draft because it requires a different. It is a different discussion. For all the other parts, the handling resource vulnerability, there is already a work in progress. I feel 6TiSH, the enrollment draft, sort of handles it for the 6TiSH, the rank priority. The same mechanism can be used here in Ripple as well, so that it informs the downstream nodes whether there is enough capacity on the upstream path. So our plan was to actually work on these problems, get some data statistics, prove that the control overhead is much large in certain cases, and then come back to the working group. That is the way that we had thought about. One more thing that we wanted to discuss is there are other implications when it comes to multiple link layer, use of multiple link layer technologies. So in our deployment, we are actually making use of PLC and 802.15.4 in sub-gigahertz at the same time. And there are some issues that we saw. One of the issues I mentioned here, but maybe I won't go into the details of this problem. Maybe the reason why I've just mentioned here is so that I just want to highlight that should we take into consideration these problems as well, which are related to use of multiple link layer technologies at there. Great. Okay, then maybe this is something that we can add to the draft as well. Thank you. Any questions? Yeah.
Thank you.
Thank you.
I really hope you progress as you promised you would. Okay.
Thank you, Raul. Charlie?
How's that? I'm Charlie Perkins. I'm here to talk about AODV Ripple. We not too long ago released a update for the draft, and so this is in response to comments that were received during last call, and I'll just take a couple of slides to go over that. Okay, well. So there were some questions about sequence numbers, and that was clarified in the draft. There was a sort of it's been mentioned a couple of times. They requested, why don't we use the DODAG version number in DTSN? Well, the main reason was because early on when the draft was being done, the large part of it, we didn't understand exactly how DTSN was supposed to work. And I asked a couple of people and still didn't get a full understanding. So now I think I do have a better understanding of it, but it still doesn't really seem to be appropriate to use it in the same way because as it's designed within Ripple, because the version number is always 0 and the DTSN is for the DAO, and there's not a DAO message in AODV Ripple. Well, that's not to say it couldn't be done. Since we have a different mode of operation, we could change the meaning of things and use that. But it seems anyway already the sequence number operation is handled well the way it is in the current draft, and it does what it's supposed to do. So these sequence numbers are now, well, they're 8 bits. So in the recent draft, it was suggested that we make those into the lollipop counter sorts of for the rollover operation, and so that was done. And this discussion that Rahul just had with the lollipop counter, I think, applies in our case too. And so we probably do need to make further clarification on what the linear part is and so on that. And that I think is. But right now, it just refers to that the lollipop counter is done the same way as it's done in Ripple. So that might be good enough, but I think we should be sure about that. And then to answer some other questions about how the sequence number is used. So the originating node increases the sequence number the same way whenever it wants to find a new route. And that's in the route request DIO message. Also, our originating node can put in a target sequence number, which is meant to say that it's not interested in getting routes unless the sequence number is greater than what it already has for the target sequence node. And that is intended to eliminate the possibility of accepting route updates for operations where the packets are still somehow being forwarded in the network. This is all pretty much modeled on the way AODV did it in RFC 3561, and also AODV version 2, which is currently under review. But so that's how that's supposed to work. And then the intermediate routers also follow pretty much the same sort of philosophy. They only update their route entries when the sequence number is greater. And finally, the target node includes its sequence number in the route reply when it sends a route reply back to the originating node. One thing that I didn't put in the slides, but I'd at least like to mention is that there was in the earlier, it was requested that AODV Ripple also enable handling of multiple targets, and that was done by having an AODV Ripple target option. And one of the larger editorial changes in this version of the draft was to just, instead of always writing out AODV Ripple target option, now we have the ART option. So that made some of the text a little perhaps easier to read. In addition to that, it was pointed out that our lifetime maybe wasn't quite big enough, so that the values now for the route lifetime that are indicated by the L field, which is a 2-bit field, have been increased. I'm running out of water in my mouth. IETF, that's really a great organization. Thank you, Chairs. Okay. Question? Okay. So the source routing, this is another feature that was added earlier in response. A lot of comments were received earlier this year and last year about, well, why don't we have some features that were present in RFC 6997? And so now AODV Ripple was improved to handle source routing as well. And so these address vectors only exist at the originating node and the target node. And so that's where the route lifetime would be effective. In hop by hop mode, if you have routers along the path, then the route entries will be updated when they receive route replace, route reply with larger sequence numbers. And if the routers aren't on the old path, then eventually, I mean, on a new path that's created, but for the routers that are not on the new path, then the route entries will just be expired. And so that's pretty much the way that works, also modeled on what was in RFC 6997. So that is pretty much it. There wasn't very many changes. If you do a diff between version 4 and version 5, you'll see that it's mostly editorial, especially with this ART nomenclature. And I think that the draft has responded to all the comments that were received during last call, but it could be that there needs to be a little bit more tune-up according to some of the discussion about lollipop counter specification and so on. So I guess we'll take a look at that and see what to do next, and maybe we'll be done.
I want to look through the document, see if I understand it completely, and probably may do a last working group, last call then for this document, and then I hope it will be ready.
Okay, that's, I mean, that would be appreciated. And I think we're sort of in last call, but more last call is.
The additions, this, okay.
Yeah, no problem. Great. And yeah, if you email on the list or whatever, you know. Get it. Thank you very much.
Thank you, Charlie.
Hi, I'm Aris. I will be presenting the next steps in our work for the traffic-aware objective function. So since the previous version, we have changed the definition of what the value reported in the metric container was. We used to report the packet transmission rate, which is similar to what Rahul has mentioned in the mailing list. And now we actually report the remaining throughput, and I will explain the difference. We have also addressed parent selection and DODAG selection. And we have defined some configuration values for how to measure the, there's something there, how to measure the used throughput in order to calculate the remaining throughput. And finally, we've also described how to use this within enrollment in relation to Michael's work. So as a quick recap, there are multiple objective functions to use in order to pick a preferred parent. You have objective function 0, which uses ETX and doesn't use a hysteresis. Then you have Mr. Hoff, which uses basically any additive metric and uses hysteresis. And there was also a draft which is called LBOF, which reported the child count of a parent and used hysteresis in order to do load balancing. Now, the problem that we're trying to solve here is related to load balancing. So we have nodes which are overloaded, and you might actually have DODAGs which are overloaded in terms of traffic, which leads to a lower lifetime for the network and the nodes because the energy consumption is not smoothly distributed. And depending on scheduling, you can also have higher packet losses and higher packet delay due to extra queuing on the nodes. So what we propose here is a combination of an extra metric called remaining throughput and an objective function. For the metric, we use it in aggregated mode with a minimum function, and it basically does tracking as the node operates of how much throughput has been used, how much forwarding a node has been using within a specific window of time, here configured through a variable. And then if you know how much capacity for doing forwarding you have. You subtract what you have used out of that, and you get the remaining throughput. So that's basically a metric of how much space you have extra for sending data around. In addition, we also define an objective function, which basically picks the node with the highest remaining throughput as a preferred parent, and you can also do a hysteresis like Mr. Hoff to limit how much switching of parents you do. And there's a small example of a DIO here, and we basically add this within the DAG metric container. And here is an example of the remaining throughput. So it's just a normal metric object. We request a new type for the routing MC type. It's noted that we need to use the minimum function in the A field. And it's basically 2 octets, 2 bytes, which report the number of packets sent within the last throughput period. So this is quite similar to Rahul's work. The only difference is that we report the remaining throughput, not the used throughput, and I will show in a few examples now. So in this case, on the left hand, it's the same network on both sides. On the left hand side, you have the unbalanced network, on the right one, the balanced one. And in this case, all the leaf nodes, the ones, is there a laser here? Yes. The leaf nodes down here all require the same traffic. It's 1 packet per second as an example. As you can see, A here has a total throughput available of 2 packets per second, which it can handle, and B as well. However, since it has 3 children, it's overloaded, whereas B has some spare capacity. So if you want to balance this, one of the 3 nodes here, C1 to C3, needs to move over to the B as parent. Now, in this case, the LBF objective function would work quite well because it just so happens that you have the same number of, all the children have the same throughput requirements. However, in this next example, if all the children, all the leaf nodes don't have the same traffic requirements, then LBF won't work. So in this case, for example, A has some spare capacity, and B is overloaded because this child requires 3 packets per second. So in this case, you basically need D2 to remain with B and D1 to switch over here so that both are within capacity. We also have some examples relating to DODAG selection. So in this case, you have a node C which is trying to pick a DODAG to join to, and you have 2 DODAGs, 1 and 2. Both of them are within capacity, but one is right on the limit. So it can handle 4 packets per second, and it is actually using 4 packets per second right now. Now, if you don't have this remaining throughput information, what will happen is that you might pick DODAG 1 to connect. And in this case, you're over capacity. And if you don't use RT, use ETX or something like that, maybe after some time you'll realize that you're getting some packet loss, and you will switch to the other one, but it will take some time to do that switch. Yes, sorry.
Pascal here.
Should I go back?
Throughput is a very dangerous metric to be used in a routing protocol. We've known that since ARPANET, so it's kind of not new news, because you tend to create oscillations in your network. Like this guy advertises more capacity, everybody moves to the side, and then obviously the capacity is bloated, and so everybody moves to the other guy, and bang, bang, bang. So I don't see that you can do a lot better than ARPANET in a distributed fashion if you stick to the idea of a preferred parent or just one next hop. So the knowledge of throughput is very useful, but it's useful to slowly rebalance across multiple parents. So if you have those parents and you use them like this, and you see that one has a bit more capacity, then you move a little bit of your traffic to that parent, but just a little bit at a time, and then you see how the whole network rebalances. And then if there's still more capacity to aim, you switch a little bit more traffic. But you keep using all your parents. Otherwise, you're in ARPANET. And your network will bang, 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 oscillate. So as long as you present it like you do with just a reparent,
So you think that a hysteresis function won't be good enough for this to control this abrupt changes?
I think you need to avoid oscillations. I think that you need to use multiple parents in parallel if you
Mhm.
use that metric, not just one.
Okay.
And slowly adapt and see what your change does, etc. So that you go from a stable state to a different stable state,
Mhm.
as opposed to create wide oscillations.
Okay, so as far as I can tell, your objection is not so much on the idea of carrying this information as to how the objective function will use it, or how each node will
Right.
use this information.
Exactly. I agree with the information we wanted. I don't agree on the behavior, which would be change your default, your preferred parent, and send all the
Mhm.
traffic to the preferred parent.
Okay. Do you think there's a meaningful way for a node to know how to switch this information? So it will have to have an idea of how to split its traffic around, right?
Exactly. It's a load balancing thing that you slowly tune. So it's Ripple gives you a DAG, right? So you have multiple parents. This is a metric that comes in a world where you use all those parents and you tune different facets. That comes with it. So it's a cool thing to do in Ripple because of those multiple parents, but don't do ARPANET.
Okay. Yeah. Thank you. Well, now I have the rest of the presentation using this. So okay. So one of the issues, it relates, it's actually good that we finished this, because one of the things that we are discussing, the next one, relates to DODAG selection with multiple metrics. So in this case, for example, you have multiple DODAGs to pick, to choose one of the DODAGs. So for example, here you have a pledge node in the middle, and it has to pick between 3 DODAGs. And the 3 DODAGs have different remaining capacities, but each of the potential parents this pledge node can connect within those DODAGs have different ETX values. So if you can use a combination of 2 metrics, for example, with highest priority being the remaining throughput and second priority being the ETX. And using that, you can pick both the best, the highest remaining throughput and the lowest ETX. So if you do that, for example, in this case, the highest remaining throughput is in DODAG 1, and within the 2 children that are accessible here, it's node B, which has the lowest ETX. However, it might be interesting to check whether you want to filter out some values of ETX. So maybe ETX 7 is too high. So then you also add a constraint in the metrics, and you tell it, you know what, if I need to only pick a parent which has an ETX lower than 7. And that means that these 2 nodes are filtered out because they both have an ETX 7 or above. And then from the remaining options, from this DODAG and this DODAG, you pick DODAG 2 with C being the highest value. Now the problem is that you might actually be too restrictive in your filter. And in this case, if you use an ETX of lower than 5, for example, then both these DODAGs are filtered out and you only end up with this DODAG. However, this one has no remaining capacity. And in this case, it would make sense to use an optional constraint, in which case you could do some extra backtracking and use a DODAG which normally doesn't cover the constraints. However, it does have a valid value for remaining throughput. We also handle enrollment in the new version of the draft. So one of the interesting things is that while what Pascal said does make a lot of sense, maybe it's not that important for the join process itself. So for the once join process, you might want to directly use the best parent. I don't know if he agrees. So for the enrollment process for layer 2, we have defined how you would convert the remaining throughput into the pan priority field that Michael describes. Since the pan priority value is basically opaque, we don't really require, it's not really important that you require the exact remaining throughput. It's just a relative value between different products. So in this case, we've decided to use a log function because the remaining throughput is a 16-bit value and we need to compress a somewhat smaller value. So we take a log on it and we convert it into the pan priority by doing a subtraction so that so that a higher value of RT turns into a lower value of pan priority. Using the log function actually helps that we have higher accuracy in the lower values of remaining throughput. So there's a bigger difference between if you have a remaining throughput of 1 versus 3, whereas for higher values of remaining throughput, it doesn't make us a big difference. And while I know that it's not generally a good idea to implement such complicated functions, at least for this case, you can implement it with a bunch of shifts and ORs and a lookup. So it should be efficient enough. Finally, something that we've already mentioned, the enrollment for Ripple. So again, as this example shows, we can use it for picking DODAGs as well. So one is for layer 2 and one is for layer 3. So finally, we've had a review by Derek and we have addressed comments in that. We have presented a paper in a conference in 2008 and we have a Contiki implementation which is very close to release for this draft. So I would like to ask what the next steps would be, if someone else would be willing to review the draft or if there's changes we should make and what the path, if any, for adoption would be. Thank you.
Thank you. Someone willing to review this document? Okay, thank you. Yeah, too. So
Thank
next steps would be like address what Pascal say and go for adoption.
And?
Go for adoption.
Okay, thank you very much.
Thank you very much. Yeah.
Hello, my name is George from UMT Atlantic, and today I will present you some updates. Basically, will be simulations that we run, set of simulations, and I will show you some results on the draft that we are working on NSA extension. So we got reviews from Diego during the previous days. So thank you, Diego. I'm not sure if he's online. No. So we it was like polishing, stylishing comments on the draft. So the 0.3 version applied these Diego comments. And the second point that I will focus today is about the results that we run since IETF 102. I'm not sure if I have time. I will go through briefly what's the concept of this draft, and then I will show you the results. So basically what we have here is to employ PRE over 60s network. And the objective is to bound the delay and to provide reliable communication. And to do so, we have these 3 operations: the replication, elimination, and the overhearing procedure. So basically, we have the replication when S sends his data packet to his preferred parent, and then he replicates the same information to his alternative parent. Then elimination procedure is at the reception side when the device, once it receives the original packet and then he receives its duplication, he will eliminate this copy. While the third operation is the overhearing. This, thanks to nature of the wireless communication, when S transmits to A, B may overhear this transmission and vice versa, when S will replicate the packet to B AMA over here. Thus, we double the opportunities for a packet to go up in the DODAC. So in this draft, we propose a way how to select the alternative parent, and we define to select alternative parent based on common ancestor. And here is the example. So basically, in this use case, S will select B as an alternative parent because they are having common ancestor, which is D. So D is the preferred parent of a preferred parent of S. So we call it grandparent. And apparently, D it is within the parent set of B. So B is a good candidate for S to be as an alternative parent. To do so, we need to update the DIO control packets, where within the metric container and within the NSA option, we define a TLV called PS, parent set, and within this parent set, we list set of IPv6 addresses, where the first one is the preferred parent. So for S, for instance, sorry, for A, when A will forward this DIO, when A will send this DIO packet, we will have 3 IPv6 addresses, where first will be its default parent, the preferred parent, and CE will be the parent set. I will go quickly from this slide where we have the example of the DIO format. Then we go to DAG MC type 2. And then the next slide here is our NSA option, where within this we define PS parent set type, where we have this set of IPv6 addresses, or compressed, thanks to Michael's comment from last or 2 IETF meetings. So so far we implemented 3 different versions of common ancestor alternative parent selection, and the first one we call it strict, where the alternative parent for S will be only the device that has common explicit preferred parent. Basically, my grandparent will be the preferred parent for my potential alternative parent. In this case, it's valid only for B2, because B2 has as a preferred parent F, which is my direct grandfather. So this is called strict mode. Then we have the medium mode, which basically says that my grandparent, the preferred parent of my preferred parent, will be within the parent set of my potential alternative parent. So to give you some examples, so apart from B2, B3 can be my potential alternative parent, because F, which is my preferred parent of my preferred parent, it is within the parent set of B3. So B3 consists of F and G. So in the medium version, B3 can be an option to choose as an alternative parent. And finally, we have this relaxed version. It basically is intersect of 2 parent sets. So basically, if any of my if any of the parent set of my preferred parent is within its overlaps with the parent set of my potential alternative parent, then this alternative parent can be defined as my alternative parent. So in this case, even B1, we have the overlap of E can be potentially my alternative parent. So this is the relaxed mode, and we did not run yet experiments with this because it really makes flooding in the network. So, but I will show you some results for our 2 previous options. So here we run a set of simulations. So on the left side, we have this default REPL with a single parent. And then we have 2 packet replication elimination options. So the first one here is, again, the default version of the REPL, where the default parent and the alternative parent are selected by default based on the best 2 rank parents. And then we have the option, packet replication elimination, CA, we call it, common ancestor, with a strict mode. So the result shows that definitely PRE improves the reliability when you compare to default REPL. And little bit, the PRE, we call it here ETX, it's better than the strict CA by 2%, but there is a cost to pay for this, and the cost is for instance, in this case, the number of devices that the single packet traversed in the network, meaning that how many devices this single packet went through based on these duplications. So you can see here this PRE with ETX went through more than 14 devices. Yes.
Peter van der Stok, just an illuminating question for me. Does the simulation take into account failing links, or are all the links up and running for 100%?
They are the links more than 70%, yes. Between 17 to 100, so there's a variable links. Thank you. And then in this slide, you will see when you the cost that you have when you traverse too many devices. So the more you traverse the devices, so the more you duplicate. As you can see that with common ancestor, we have a difference of more than 40% in terms of the duplications in the network. So basically, it's the unnecessary packets that we save when you run this packet replication elimination with common ancestor algorithm. So what we wanted to do next is to see how it works in the topology here. This is a snapshot of default REPL with single parent, with single path. So this is nothing, no surprises here. And then we have this packet replication elimination with based on default REPL with two best parents, basically. And you can see here the level of the flooding that you have in the network, right? And of course, this improves the reliability, but you pay the cost in terms of the energy and duplication that you have in the network. And then the solution, the scheme that we propose here, the CA strict, you can see the ladder topology that we have here, we achieved. So you have these two parallel paths until the destination. But the only issue is that sometimes we may end up not having the alternative parent. So this is when we running CA strict, because not always the two potential parents are having their common parents. Like thus, we don't have sometimes alternative parents. So this is not always, but sometimes we have this case. Now, to avoid this case, we thought to run the medium CA, so the second version of the common ancestor. And our results shows pretty interesting results. So you can see that we improved the reliability. We even surpassed the packet replication elimination with it based on ETX. So we have really good PDR, but we pay the cost as well. So the cost is we increased the number of devices that we went through, traversed, in order to get the packet to the destination, which eventually we pay the cost in terms of energy because we have more transmissions, we have more duplications. But in order to somehow mitigate this problem, we discussed with Pascal back in ADOC conference in September. The idea is that to avoid having this problem here, to have too many devices that forward the same information. So the idea was, if you end up in a use case where you have only one device in the network, we introduce a bit in the packet so that we will allow to move from the strict mode to the medium mode. And actually, this use case helped us. So basically, every time we call it this strict to medium, so all devices are around CA strict mode. And once we allow the devices when they are having trouble not finding the alternative parent, we allow them once in the network to switch to medium CA to find the alternative parent if they cannot, to open the branch basically. So by doing so, we improved the PDR. We somehow mitigated the number of devices that we went through, and this helped us to reduce by 14%, more than 14%, the duplications in the network. So this is ongoing work. So these results we got like 2 days ago. So we are still working on even more to improving this, to put some intelligence, how to reduce even more these duplications. Okay, so that's all I think that we have so far. So road forward. So yes, this work was presented last for IETF. We have partial code online. So we have the Contiki version of the NS extension. You will have here the link. We have these Wireshark dissectors for the TLVs. It's online as well. We got reviews, so this is good for us now from Diego and from Derek. We want more. Something interesting, we start using this in education as well. So we first did a tutorial this year in GIS conference of 2-hour tutorial. We had 25 to 30 attendees. It was quite interesting discussion later. And we are using PRE in our teaching. So at our school, we are employing 6 to 9 hours of teaching on ContiQOS with lab sessions. So it's quite interesting for the students as well. And then we have some research on both conferences and journals. Here's some credits to all guys who helped us so far. Yes.
Rahul Jadhav from Huawei Technologies. My first question is regarding how do you apply PRE only for the subset of traffic? For example, I might have maybe 1% of traffic where I am okay with to induce such kind of energy cost, so that I can have more. I can use this technique on. Basically, my point is I want to use this technique only for the subset of traffic. Okay. How do I do that? Because there is a cost involved. This is my first question.
We did not touch yet. So what we do for so far, it was like for all our traffic. But it's a nice point. We can try to do this for our partial traffic as well. We did not try yet.
Pascal here. Okay, so this PRE inherits from work which has been done in DetNet and things like that. And certainly DetNet identifies the flows for which particular attention needs to be taken. And PRE itself has a header that indicates like a sequence number and so that you can eliminate replication and which flow it is and this sort of thing. So this is about how you can transport this in the network. But obviously there will be something else which is not this draft, which will indicate whatever is needed to do replication, elimination, etc. And this is why we have this POE discussion on Thursday, right? How do we enable mechanisms to get better results on wireless, which take us closer to the spirit of deterministic networking, even if people won't like to call wireless deterministic for a number of psychological reasons. Still, we want to get similar benefits on wireless as we do on wires with deterministic. And so POE is all about this, and this is one of the ways to do it. So it just shows you as an example that there are things we could do at the IETF which would allow a more deterministic use, more deterministic delivery of your packets. And that is nothing to do with IEEE, right? It's really an IETF problem here that we can. So POE, Thursday, 11.
I mean, in this paper, maybe I will show you some results in the next IETF. In this journal, we show that we bound the delay to 15 milliseconds. The jitter, excuse me.
So the experiments were done as part of Kuja, I believe.
Yes.
Look, I feel personally, in my opinion, I cannot use Kuja for such kind of experiments, where it does not have realistic error. If you do the same experiment in NS3 or Castalia, you'll have a different result altogether. That I'm very much sure about. Okay, so so if I heard it correctly, are you saying that the actual data traffic the forwarding plane will have some sort of IPv6 extension header inserted in it, so as to know what flow it belongs to as part of? Okay, all right, okay, I get it.
Thank you. Yes.
Thank you, Georgios. Who has read the draft? Okay, who is willing to review the draft? Okay, Raul, thank you. Just based on this presentation, Raul. No one else? Okay. Based on this presentation, we would like to know what do you think about if we should adopt this document. So please, Ham. Against? Reasons? The reason?
So there are sorts of traffic now that we are seeing in the AMI space, which is more in the control area than in the pure metering, right? So those networks now that we deploy are going beyond pure metering and need more reliable transport for some more control type of activity. And for those things, actually, our customers are asking something like storing mode and something like deterministic. And we cannot really give either of them, but we can approach that. And this is typically a technique that can help approach determinism on those networks. So it's actually something we need in the field. So that's why I'm humming. For the storing mode, that's really where this rod projection comes in, because the current means we could not do storing mode in large scale. So we came up with rod projection. But for reliability, we need something like that. And actually, if you think about combining this with rod projection, then you could project 2 rods and decide to do PRE over those 2 rods. Kind of. That's one example of things. So you, instead of having to discover those 2 paths like we do automatically, now if you combine this with rod projection, the controller could decide the 2 paths and decide all the crossing thing. So that there is a way in front of us to provide more deterministic behaviors on those networks. So that's what's behind all this.
Thank you.
I'm Charlie Perkins. I don't have actually opinion for or against, but I was just a little bit surprised about technique for picking out effectively grandparents. I mean, is it?
The reason behind this technique is to avoid the first flooding. So the idea is we want to keep as close as to the main path that you pick up from the ripple, based on the ripple and the rank. So we try the alternative parent to be always close enough to this path so that we avoid this flooding in the network. As you can see, maybe in this figure, we want to avoid this basically.
Okay, so you want to have sort of narrowly constrained flooding, and in order to do that, you want to exert some control over the grandparents.
Yes.
And then presumably, as part of the mechanism, the grandparents exhibit control over their grandparents, or?
Yes, yes. So exactly. This is what we.
So
we want to achieve this basically.
So
more or less.
That seems to make a lot more sense when you have 25 nodes in a square array, but I'm not sure how it fits into an actual network.
Meaning?
I don't know.
You need enough density to be able to select that. Otherwise, yes. So if your network is dense enough,
So here you have network out degree maybe like as much as 9.
Yes. So there is a density where these things make sense, and basically the whole benefit of meshing is that you have multiple possibilities. And if you have multiple possibilities, then hopefully you get them all the way through to the root. And if you get that, think about it for a minute, right? Radio is lossy. So you're sort of thinking, hey, can I use radios for my application if it's kind of important for me, right? And on the other hand, if you realize that radio has this benefit that there is more than one guy who can hear you when you talk, and you can use that other specific thing of radio to balance the first one. On the one hand, you talking to just one person is lossy, but in the other hand, other people can hear you, which gives you extra receive. Can you balance those two? Can the solution of the prime one be found in the same behavior of the radio, which is the fact that multiple people can receive you? And can you balance that? That's exactly what we are doing here. So at the end of the day, we get a reliable transmission because we balance the lossiness with the fact that multiple people can receive you. So you must get away from the wired paradigm of this hop and then this hop and then this hop, and start thinking in, I'm progressing like a wave from A to B. And what we are doing exactly is what Charlie said, we are kind of constraining how this progression happens. You don't really care if it progresses like through those guys or through those guys, but you're kind of building a multi-lane way between you and the root. And you could use at each hop any of those lanes to progress. But you're progressing like a wave inside this waveguide that we are building here. What?
A wave, not a particle.
Yes, a wave, not a particle. It's a field. Everything is a field. So in this field, So, but that's exactly what you're doing, right? You're progressing like a wave across this medium, which is this. If you think like a one hop and then one hop and then one hop, if you think wire, then you end up with a very lossy medium. If you think like a radio, now you can be reliable again. Make radio great again?
Thank you.
Well, I won't belabor the point.
Closest
Is that-
to the mic.
Are we done?
Maybe you can take your micro.
Oh,
Yeah.
So I don't want to belabor the point. It's probably better on the mailing list, but I think it would be better to show some more general simulations. And also, there has been a lot of work done on what's called backup routes. In other words, instead of having one path through, you have a couple that maybe are relatively close tracked, controlled by the metric. And yeah, okay, thank you.
Which was my point with our projection. The thing here is that they interfere with
Hi, this is Aris here. So 2 points. One, regarding DAO projection. So this solution is basically refers to when you don't have a central controller which can define your route. So if you don't have that available, this is basically the best you can do, right? The second thing is, as far as the draft is concerned, Georgios has presented more simulation stuff like that, but at the end of the day, the draft just proposes another optional TLV inside the NSA metric container. So the size of the draft is very constrained, and I would like to ask if it would make sense to add more of the PRE stuff inside it, or if it makes sense to remain like a relatively focused thing on just this extension.
Okay, thank you for the comment, Ari.
You want to? Yes, I will skip that one, I guess, because we don't have much time. So, yes, we just have 5 minutes. So the route projection did not progress much because I didn't get much review on it. So let's, please look at it, give us reviews so we can progress, because for the time being, it's kind of stuck. So we'll just keep that, and you will see there are many slides here for those who are not so familiar with it, on how it works and what happens, etc., etc. The whole thing is the DAO projection is taking Ripple into the SDN world. You have a controller, you can establish storing mode along non-storing path to compress the routing headers, and you can establish horizontal tunnels so as to bypass between the source and destination, avoiding going all the way up to the common part. And with this, I will go straight to unaware, Ripple unaware leaves. Oh, okay, well, 4 minutes. So giving you news, there are 3 things really that this draft does and a number of things that it does not. And what I would like the group to tell me is what we want in this draft and what we don't want in this draft. So right now, what the draft is doing is very simple. You've got this host. It's not Ripple aware. We are using RFC 6775 update for a leaf node which is not aware of Ripple to register to Ripple for unicast transmissions. And that's where Torles needs to think about it for a minute, because that's the point you made, and I'm confirming it. We are using this just to advertise an IPv6 address between a host and a router, so the router can do Ripple on behalf of the host. We don't do multicast. So if you want to do multicast, the idea today is you use MLD, the way it works. And that's how you would register a multicast address. Now the router, based on that, on MLD or this, could turn the IP address registration into a bit if it's aware of beer, and advertise that all the way up as a beer thing, as opposed to a multicast address in Ripple or a unicast address in Ripple. That would be one way, and that's what we called kind of tunnel mode or something. Well, anyway, that's because you had so many names, but that's when the leaf is not aware of beer at all. If the leaf is aware of beer, then we would need an extension there to signal the bit from the leaf to the router, which does not exist today. Torles, I have 4 minutes for my whole presentation, but I'm just 2, right? So basically, this draft here, this RFC 6775 update, is how you register this unicast address all the way to the 6 LBR, which is or not the Ripple route, and that's yet again a discussion we need to have, and all the way back. So for the time being, we have separated the concept. In this draft, we have separated the concept of 6LBR, which is a 6-LOPAN concept, and what Torles called the 6RR, the ripple route. But if you read 6-LOPAN, it says it's the same thing. It's just that 6-LOPAN did not specify what it would be. For the leaf, this unaware draft, I had to design the flow between the 6LBR and the 6RR and the ripple route. And this is an extra complexity that we may not want. So that's really something that I want you guys to react upon. Do we consider that the ripple route is always the 6LBR? Is it by definition the same guy? If it is, then there are some flaws in this draft that we can just avoid. Now, if we want for some reason to keep them separate, then the flows that are in the draft are useful. Okay. Then, so like I said, this 6075 that we depend upon is now in the RFC editor queue. We'll get the RFC number like before Christmas. So that's good news because we depend on it, so that dependency will be open. Now there is another draft which comes with it. It's called APND. It's the address protection. So this thing allows the savvy properties in 6LOPAN ND, meaning that if somebody forms an address, advertises it, then somebody else cannot steal it, cannot come and say, I'm him, and attract the traffic and source traffic on behalf of the other guy. With the savvy properties that APND is bringing in, we will be able to filter the attacks at the edge of the network. So if you have a leaf which is not ripple aware and that wants to steal the address of somebody else and get it advertised in the ripple network, the 6LR at the edge can filter that with APND. It's a crypto mechanism to avoid that. But this mechanism is just valid at the edge. So if you really trust your ripple network, we're all set. But if you think somebody could sneak in your ripple network and start advertising addresses on behalf of the 6LN, then this attack would be possible. And so my second question to the group here is, do we want to extend not only RFC 6775 with unaware leaf, but also APND? Meaning add mechanisms in Ripple that would prevent an attacker to inject an address that is not below it on behalf of a 6LN, which is somewhere else in the network. So do we want to extend the proof of ownership that we do in 6LOPAN ND in Ripple? That would be my biggest question, and after that I can pretty much go through.
Could you ask these questions on the mailing list? Because I think at this moment it will be very difficult to react to you in 30 seconds.
Yeah. Okay, I can.
Yeah.
So basically I asked two questions. First, do we need to force that the Ripple route is the 6LBR or not? If they are not the same, there is extra cost in signaling when the node gets in. Do we really want that craziness? I've actually shown how it would work, but I want to get rid of it. Second thing is, do we want to protect Ripple, inside Ripple, against attacks? So somebody gets the keys of the realm, is capable to inject routes in the network. Do we want to use the fact that we have APND with the leaf to actually protect the leaves that are registered, so that a rogue Ripple router would not be able to inject a leaf which is not there? Questions to group. Is that logically part of this draft?
Thank you very much, Pascal. Well, we are going. Okay, for one question, there is a ticket already open, but it will be nice to put the questions into the mailing list. How Peter said. Okay. Okay. Thank you very much to everyone. We conclude the meeting. Thank you. Thank you.